In exercise 5, this one is similar to exercise 4 in that we have two different interest rates being applied to this account. So on January 1, 2002, Betty deposited $1,000 and she was earning interest at a nominal rate of 4% convertible quarterly. So again, we have our timeline in quarters. And here's the nominal rate that's given, 4%, and n equals 4. So the effective rate per quarter would be 1%, 4% divided by 4. And so to get the balance at the end of the next quarter, we take the $1,000 and we multiply by 1 plus 4% over 4. Now she keeps the money in that account until January 1, 2006. And so by January 1, 2006, her account has grown to $1,172.58. And then the bank upgrades her account to a gold account, which earns interest at 5% convertible monthly. So now I'm going to use this monthly rate, this nominal rate of 5%, and it's convertible monthly. So to get the amount, her balance on February 1, 2006, I would take the $1,172.58 and multiply it by 1 plus nominal rate 2, the 5%, divided by N2, which is 12. And that formula gets copied down until January 1, 2012. Down here somewhere. There we go. Okay, so she ends up with $1,581.83. And then she closes the account. And we want to compute Betty's average effective annual interest rate for the period. So in other words, we want to know at what rate, if she had earned a constant rate throughout the 10 years, would she have ended up with the same ending balance. So I'm going to make a guess for the, and we're not asked actually for a nominal rate, we're asked for an effective rate, compute the average effective rate. So for that, I want to set up my timeline in years. So I start with 1102, then 1103, etc. I start with 1,000, and I use whatever my guess is for the effective rate and multiply by 1 plus the effective rate to get the amount at the end of the year, and so forth from for 10 years, and I end up with 1552.97. But I want to end up with the same ending balance as before, so I take the difference, E12 minus B90, and I use the solver to make that 0 by changing the effective rate. So I'll let that difference equal 0 by changing the effective rate and solve, and we find a solution, and it's 4.693%.